To wrap things up, we are going to hit the first few sections out of chapter 7. All of the trig that we've done so far has either been based off a circle or a right triangle. Now we're going to extend it to how do we solve it if we have a non-right triangle? Because our definition, SOHCAHTOA, you have to have a hypotenuse for that to work. And the hypotenuse means you have to have a right angle. So oblique triangles, if we're talking about those, that's just any triangle that is not right. If we're going to be able to solve it, and remember solving a triangle means finding all the missing angles and sides, we have to know at least 3 measurements from the triangle. And at least one of those has to be a side. So we can't just know 3 angles, because that could represent a lot of different triangles. But if we know at least one side and 2 other pieces of information, then we will be able to solve our triangle. So, to do this, we are going to use the law of sine. This is on your formula sheet, just the back side of your formula sheet, because you probably never flipped it over. In any triangle with sides A, B, and C, A over sine A equals B over sine B equals C over sine C. So you can set any 2 of these ratios equal to one another.
Big A is a side, is an angle, right?
Yep. Okay, this doesn't contradict SOHCAHTOA, because if we think about like in a right triangle, ABC, okay, for instance, if I said like A over sine A equals C over sine C, C is a 90-degree angle. What is the sine of 90?
0.
1.
Oh, wrong.
So that means C times the sine of A equals A. So sine A equals A over C. Isn't that opposite over hypotenuse? And you could do the same thing if you were working from angle B. So this doesn't contradict what we already know. It's just a more generic version that we can use in any triangle, not just right triangles. Okay, so let's take a look at a problem. Solve triangle ABC. That means all angles and all sides. If angle A is 32 degrees, how many significant digits is that, by the way?
That would be 3.
Angle B is 81.8 degrees, and side A is 42.9 centimeters. I would draw pictures on these and label. Doesn't have to be drawn to scale. So side angle A is 32. Side A goes across from angle A. So to use the law of sines, we can take any 2 at a time. Now if I'm going to be able to solve for anything, I'm going to have to use the A over sine A, because that is the only angle side pair that I was given in the problem. So let's solve for side B. So I'm just going to use that A over sine of A is B over the sine of B. So side A is 42.9. divided by the sine of 32 degrees equals side B over the sine of 81.8 degrees. Then how would you solve for B?
Multiply by.
Okay, these are going to be calculator problems. What mode do I need to be in?
Degree.
Degree mode. So I have the sine of 81.8 times 42.9 divided by the sine of 32. How many significant digits?
3.
3. So side B is 80.1 centimeters. Okay. Don't round until the very end. So you don't want to like type 81 sine of 81.8 degrees in your calculator, get a decimal, and then round that and then multiply over. Keep everything exact until the very end. Now, unfortunately, can we just do Pythagorean theorem to get the missing side?
No.
No, because it's not a right triangle. We can find angle C pretty easily. How could we do that?
Use the calculator.
In a triangle, all the angles add up to,
180.
so you could do 180 minus the two angles we have.
66.
Then how am I going to find sine C?
Use A to find C.
So we can do the law of sines. A over sine of A equals C over sine C. 42.9 divided by sine of 32 degrees equals C over the sine of 66.2 degrees. The sine of 66.2 degrees, because that's what we got for angle C.
Did you say that we do that in first class?
No. So all you'll have to do is multiply over the sine of 66.2, 3 significant digits, so 74.1.
When we're doing this,
Mhm.
we want to start right the formula we're using.
At the very least, you need to write this step. Show me something. All right. Quick check at the end using some triangle properties here. My smallest angle was A. That means side A has to be the shortest side. Was it? My biggest angle was B. Was side B my biggest side? So that's just a quick check you can look at to make sure you were on the right track. Okay. Is that one all right with everybody? Let's do. My next other suggestion: try to use the given numbers whenever you can to avoid rounding error. So like right here, I went back to the A sine A instead of using the B that I found. It should be the same, but there is a little more rounding error. So if you can use original problems, that's best. All right, let's try this one. Kurt Daniels wishes to measure the distance across a river. He determines that angle C is 112.90 degrees. Angle A is 31.10 degrees, and side B is 347.6 feet. Find the distance A across the river. All right. So, if we drew a triangle, mine is definitely not drawn to scale. Angle C was 112.9. Angle A, 31.1. side B, 347.6 feet. I want the distance A. That's going to be my distance across the river.
You should find B's angle.
So I know if I'm going to find side A, I'm going to have to use the A over sine A. I have to have a set of information, an angle and the side, to do that. Did I give you a matching angle and side?
No.
No, but I gave you side B. Can you find angle B? Yeah, 180 minus the angles that we have.
Is this when it's appropriate to use our ones that we found? Because we have to.
Yes, you don't have a choice on this one. So angle B is 36 degrees. So I'm going to do A over sine A equals B over sine of B. Don't know A over the sine of 31.1 degrees equals side B, 347.6, over the sine of 36 degrees. So then we just multiply over the sine of 31.1. And what do you get?
305.5 because you.
Okay. How many significant digits were given here?
1, 2.
Yeah. That one was 5, but this was 4, and this was 4. And remember, the rule is you use the least number, so we go to 4.
I don't know. I tried to say 1 because that's how many were after the decimal.
Yeah, 1 decimal is what we needed. All right. Doing okay on these so far? And I have more examples if we need them.
Not an east-west line.
What?
Isn't that the one we have to do the silly thing and then?
Bearings?
Yeah.
But bearings aren't they off of right triangles or like
They're off of a north-south line. We had to have right triangles in the past in
But
order
this
to
time
find
we're not.
anything. But now we have law of
but
science.
there's a north
No,
south.
but I'm bad at bearings.
So, 2 ranger stations are on an east-west line. So what kind of line is an east-west line?
Horizontal.
110 miles apart. So here's point A, here's point B, distance between 110. A forest fire is located on a bearing of north 42 degrees east. This is an excellent time to review something. If I'm going to do bearing, what do we have to have?
North, south.
So we have to go north, east, and this is 42 degrees. Remember, the angle is measured from that north-south line. Okay, it's on a bearing of north 15 degrees east from the eastern station. So if I did a north-south line, same fire, this angle is 15 degrees. How far is it? How far is the fire from the western station? Okay, so which one's my western station? A. I want to know how far the fire is from it, so I'm looking for side B. So we know we have to do B over sine B. All right, what other pair of information am I going to be able to get? C. The only side I have is C, so I have to use that. All right, so if we plug in what we have, side B we do not know. Can we figure out angle B? Yes, because this is a north-south and an east-west line. When they meet, what kind of angle is it?
Right.
Okay, so 90 minus 15.
728.
So, B over the sine of 75 degrees equals side C, which was 110, over, can I find angle C?
Yep.
Yeah, we know angle A, this is a north-south line and an east-west, so 90 minus 42. Okay, 180 minus 48 minus 75. 56. Then we just multiply over the sine of 75. And we get that B is how many significant digits did I give you in the problem? 3.
What do we
Does that 0 count?
No.
No. So I didn't specify that you had to do significant digits, but I'm trying to review a few things when we can. So this is the answer. If I said to round to 2 significant digits,
130
we would have to go to 130.
Miles.
Yes, these are miles. Okay. Do we need more problems? You guys want to work?
Can I get my book?
35%.
3, 5 through 17, every other odd. So it's like 3, 5, 9,
I agree with Grace.
13, 17, 25. You have a whole 6 problems.